Hello and welcome to the SOM Survey Instruments and 3Dsurvey webinar. So I'm very excited about today's webinar because we're actually going to speak about the new release, which is the South African coordinate system, which is included in 3Dsurvey. So let's talk about a short introduction. My name is Viam Rabaskachny. I'll be your host in this webinar, and I come from a company called SOM Survey Instruments. So at SOM Survey Instruments, we pride ourselves in providing you as a surveyor with the most powerful, precise and cost-effective equipment around. So be sure to always check out our website and see what we have on offer. Great, so our journey with 3Dsurvey started when we realized that our clients come home after a long day of gathering photos in the field, just coming to the office and having to spend a lot of hours in front of the PC in order to generate their new 3D model of their site. We saw that 3Dsurvey offered something which the competitors didn't, and we jumped right on board with them. And we have grown with them over the past 3 years up to the stage and phase where we are now. So what you can expect in this webinar is a short basic overview of photogrammetry, and then from starting a project, the basic workflow using GCPs, creating a model in 3Dsurvey, doing basic ground classification, creating a mesh model obviously, and then creating contours and generating an orthophoto of your site. So this will be the main topics that we'll cover in this webinar, and then our next webinar will be about how to use your PPK data that you have generated or created from your drone. So that's a very interesting one, and be sure not to miss that one. So without further ado, let's jump into the webinar. So as you all know, this is the basic screen, the first screen when you launch your 3Dsurvey. This is what actually appears. So what that will do is click on new project. We'll navigate to our certain set project. We'll click on it and then just click on shift. Click on the last picture, click on open, and then we'll actually import all your pictures already, as you can see there, but there's currently no coordinate data or EXIF data, as you can see. So in order to add that data, we'll click on the drop down and we say EXIF data. So what this means is that the photo has already got its own position that you would like to use. And then the reason why we are all here is the actual coordinate system. So in the past, we always just use known and let 3Dsurvey estimate what coordinate system it used in WGS, let's say for example 35 south or 36 south, where you were. But now, because of the new coordinate system, we can actually go and select the correct coordinate system, and this opens up a new world in 3Dsurvey. So we can just click on, so type in heart in our search button, and then our Hartebeeshoek 94 coordinate system will appear. We'll select the correct one which we actually want to use, and then say select, import, and then you'll see it says that the data was successfully imported. Alright, we'll click on OK. And now you can automatically see as well that your precisions is 10 meter in your X, 10 meter in your Y, and then 100 in your Z. Because this is not PPK data, it's fine to use the settings as they are there. It's like the default or custom settings, so we're not going to change that. If we in fact have PPK data on the EXIF data, then we'll change this to about say 2 centimeters or 4 centimeters, depending on the accuracy that you processed your telemetry. But for this case, we'll just leave it as it is. So in order to know more about this, be sure to check out our next webinar as well on this. So we'll just say close. Over here we can see that the Y is a westing coordinate. So remember, when we import our GCPs, it's very important to load it in the similar manner as what 3Dsurvey is seeing it. So you'll select your Y coordinate as a westing and your X coordinate as a southing. Otherwise it will plot in an incorrect place, enabling you not to use your own GCP data. So that will not be too great. So make sure that you always do get this and use the same setting as what is in 3Dsurvey already. So what we can see here, what is loaded, is the basic field that we have done survey on, and we can actually see that there is some trees, and it's a very basic and open environment, and it's actually a good data set to do this webinar on. So the next function that you obviously have to do is then click on bundle adjustment. So we're just going to go global. On your drop down, you've got a number of features, but for this specific case, we're just going to say it's a normal feature detection. Yeah, and we're fine with that. It's going to use the telemetry that's already existing as well to estimate the photo positions, and we're fine with all that. So let's run the bundle adjustment. Alright, our bundle adjustment is done, and we could see that it took about a minute and say 40 seconds to do the basic bundle adjustment. And this is what our space point cloud actually looked like, and I think that's pretty decent. You'll see that there's some basic trees, and we can see that this is more or less what the site looked like, which means we can automatically assume that the telemetry data was in fact as good as it could be. So, but to get this model as accurate as possible, we know that we need to orientate with our GCPs. So let's go to that. We'll obviously say browse, click on our control, select open. Let's say browse, click on the control, open, and there we can see we have got quite a number of GCPs. So that's about 9 GCPs. And again, because we know the exact coordinate system, we can actually say unknown. Normally what we did is we just kept it on local because it already automatically moved the point cloud to the correct coordinate system without us selecting it. So, but because we can actually select on the known, it means that our orthophoto is also correctly orientated now, which in the past it was orientated incorrectly. So you either had to make your westing and southing coordinates as a negative to output your coordinate system or your orthophoto correctly to be placed in the correct space if you open up Google Earth. But because we now have our own coordinate system, we can just go and select our physical coordinate system and say import. Alright, and we know on this job that the custom GCP diameters was used. But if you have any other GCP diameters or target diameters that you use from 3Dsurvey, you can actually just alternate it here. Okay, because we actually know that this is correct, we're just going to go ahead and click on next. So what we'll need to do now is we've got a small basic map of our GCPs as always, and we'll just select on the first one. Alright, and then we'll click on the downwards button to move to our next GCP. You can see it there. Right, and then we can actually see there's another one. Okay, there it gives a first basic estimate of accuracy. So what you can do is, because you've already selected 3 GCPs, you can click on next. And now you can actually see how accurate did it detect your targets. And you can see 3Dsurvey has done a pretty good job of everything. One very important aspect to always remember is just that let's just tick these ones. There's nothing wrong with them. You can just right click to move it, and then this one is also fine. Maybe just a right click there, and this one is also fine. So what we can also do is just make sure that you have at least 5 photos per GCP to allow 3Dsurvey to really work as optimal as possible. Alright, so there's a few basic ones. I think that one is also fine. And over here, you can just move this around slightly. If we're struggling to see, we can zoom out a bit to make sure that we capture our full range and area. So over there we know there's our GCP, and they're all looking pretty fine. Right, this is pretty good enough for what we want to use it for. Right, so I'm just right clicking my mouse on the target, and you'll see it activates my screen and also takes it to the position on the target where I clicked it. Alright, so if I am happy and good with this, then I could typically, if you just want to activate them, you can just double click on the red ones to make sure that they're active again. And these ones are also fine. Maybe just right click on there, right click there, right click there, and then right click there. Left click to activate the boxes, and then another right click there. Alright, so I can see that the GCPs are more or less located where they need to be. So just to see how accurate they are currently, I'll just take my zoom and then just zoom it in nicely. Alright, just to make sure that I am as accurate as possible. So you'll see that some of the pictures that I've manually activated are not that accurate, but they're fairly alright. So you can just align them perfectly as far as possible. So one of the cool functions of 3Dsurvey is the detect GCP function. So as you could see, it centered a lot of the images automatically and very fast. So if we were to go back and we have to untick this box and say with this specific accuracy it must search the targets, it will not fall that accurate. Right, it's already using the existing data that I've used. Okay, but we can just say next. So what it's doing now, it is just calculating your GCP orientation and actually how accurate you worked. So the more accurate you select your GCPs and make sure that they are spot on, the more accurate your end results were. So I didn't even do it as perfect as possible, but as you can see, my results on my 9 GCPs is fairly good. And we've got about a 3 mil error, a total of a 3 mil error on some of the points, and then 1 mils and 0 mils. So you can really see that we can expect some good results on this point cloud. So I'm happy with that. It shows me my GCPs, and just to make sure it is on the point cloud, you can just rotate your model and just move around to see that it is in fact on top of the model. Alright, so very good with that. And then once we're done with that, we can just verify that the accuracies or the error that we can expect is more or less that. and we can start with the reconstruction. Alright, so just for this use case, we can just gonna sit on a medium point cloud, and we don't need surface-based optimization. If you do not have a graphics card, you can untick this and then just tick your surface-based optimization. But if you're fortunate to have a GCP, a graphics card, then please just make sure that it's always ticked. Alright, it will now start reconstructing my dense point cloud, and as soon as it's done, we'll look at the specific point cloud, the data that we received from the point cloud, the amount of points that was generated. We'll even go a bit more deeper and execute a reconstruction, a ground classification, and we'll do a mesh, finish it off with some good contours, and then we'll create the orthophoto. So we'll continue as soon as this is done. Alright, great stuff. So as you could see, this took us only about 45 minutes, and we have received our new point cloud. And you can see there's quite a number of detail still visible and available. Even though it's a medium point cloud, there's still a lot of data that you could actually see on your point cloud. So you don't always necessarily have to create the thickest, highest density point cloud, but if you're just interested in a basic contour survey, then doing a medium point cloud is more than sufficient. Alright, so without further ado, I think let's just add some more validation data points. Alright, then again, it's very important to make sure that you select your westing and southing, otherwise it will obviously not plot in the correct position or place. Alright, there we can see is our validation points, and just to see how close it is to our point cloud, just to make sure, you can actually see that it's pretty spot on top of the point cloud, so that will make us happy. And then we can just go ahead and do some spot checks on it. Just before we do some spot checks, I think let's also load some more. Let's load the same points just as CAD data points, so that we can actually see what the difference is between in elevations. Alright, and again we'll use the known projection, and as you can see, it doesn't allow me to import. It's because some of the columns is making use of or is needing survey data. So as soon as I change that to none, I can see it's now ready for me to actually import the data. So I'll go ahead and import the data, and then let's zoom in to our first point. We'll say measure, just the normal height difference is what we need, and there we can see it's 30 mils, which is spot on to what we actually need it for. 51 mil, what's that, 10 mils, yeah, so fairly good. 60 mils, but it's a bit further away, so I think based on that we can actually see that our point cloud is actually very close to the truth, and that makes us very happy. Alright, So, and also this is a vertical check that we're actually doing here. So it's not a horizontal check, this is just a vertical check. We know that based on our data that our vertical checks should actually be spot on when we look at our GCPs. So what we just want to do is a bit of a bit bigger error, 80 mils, 70 mils, 70 mils. Okay, right, so not that bad. Right, so let's check one of these points here at the top, and I think then we'll be done with our check, being satisfied with the checks. Let's just put it there. So whenever you're busy and you want to go in closer to one of your points, what you can do is you can actually just press in shift. But as I can see there, everything is spot on. I mean, 2 centimeters in height difference is not gonna make me anxious. So I can definitely say, and this is all GPS data that was accumulated here. So remember that your GPS also pushes into the ground. So you'll always have a bit more than, it's a 2 centimeters or 3 centimeters difference from your GPS data to your actual point cloud. But just to get it this close means that your survey is actually good and you can really use it for whatever you need to. Alright, and then I think let's go a bit further, and I'm just going to switch this off and load or move over to the point cloud again, and over here I would like to do a classification. So at the bottom here you'll see there's the tool section, and what we do with the classification is we can actually classify the ground. So if we want to remove anything which is not ground related, you can obviously set your terrain slope to be less, so the smaller the degrees is, the smaller the height change will be that it allows to still assume that it's ground. When you're doing volumetric calculations, this is definitely the optimal settings, but for places such as this, you can actually decrease your degrees to give you a more smoother surface and actually a more relevant surface to what the ground really is like. But for what we want to do today, we're just going to keep it as the custom surface or as the default settings and continue on that. Alright, so first things first. Okay, click on your area that you have selected as ground. You'll see it turns red, and everything else that is not ground related, you'll see some of those bushes even will have been removed. So the red is what it sees as actual ground, and when you zoom in closer you can see that that is fairly close to what the ground really is. If you rotate the model a bit just to see, so all this high points is actually what it does not see as ground. It only sees normal red as ground, and that is good. So we'll just say finish, so that you can finish with the classification, and there we have it. So now what we can do is we can either take the ground away and keep the rest, or we can say delete other, and that will automatically delete all the high trees that we see here, the bushes, and you'll just remain with your normal ground point cloud. Alright, so let's go ahead and say delete other. As you can see, there's obviously a lot of holes now in my survey, but that's actually what we want, because that gives us a more and clearer indication of what the ground actually looks like. So as you can see, it's fairly good and fairly close to the real surface, so I think we can be safe to assume that that is the surface, and continue with creating a mesh. So when we create the mesh, also we want to create the mesh only on the ground surface. Alright, so we'll use some smoothing, and then also we'll use the hole filling method. If you do not use this, it means that all these empty spaces will obviously still stay empty, and this is not what we want. We want the model to be complete and the contours to actually flow. If it flows, for example, through a void or empty space such as this, we want it to actually still continue to flow. So that's why we actually use the hole filling method. So we'll just say calculate, smoothing the surface, and there you go. This is our model, obviously of the ground, and that's what we want. Okay, going over, we can actually check the height map. So over here is a high point, or actually a low point, sorry, and there's a high point in our site. Alright, so we're not going to use that. We're just going to go over and then calculate some contour lines. So for example, if you had a stockpile, obviously you'll use the calculate volume, indicate your area, and then calculate your volume area. But because we're just interested in a basic contour survey, we're just going to say create our contour lines, and our interval can be, let's say 0.5 meters is more than enough for us. Okay, and we'll say continue, and our contours has been generated. Alright, and then as you can see, this is our basic point cloud. This is what we wanted, and then our contours, as you can see, slightly at the back of the point cloud. So if we can just remove the point cloud, and there we'll see our smoothed contours. So that's fairly good, and this is representable. You can create a more smoother contour if you would like, but for normal circumstances this contour smoothing is fairly good, and you can actually use this and present it as final data to your client. Right, let's throw that over again, and now let's go over to the orthophoto. We want to calculate a new top-down orthophoto based on this point cloud. Okay, so the desired resolution is 3.85 centimeters per pixel, so that's your GSD, which is perfect, and we're just going to say calculate. Alright, and then as you can see, this is my contours draped over my orthophoto, and my orthophoto has in fact got my original trees back. So it still shows a normal contour flowing through the tree, even though you can actually see the tree. So it doesn't make any spirals like it would have if you had the trees visible, and that's why we do a ground classification. Alright, and then this is it. So this was a basic walkthrough, and we can now export all the data and then represent and send it to our client. If you would like to cut your area a bit more, you can do so using the cut function, and then you can just select the area of interest, for example, let's say from here to, let's say about here. If this was your area of interest, and as you can see, my minimum maximum coordinates have been updated, and we'll just say confirm. Great, and as we can see, it actually cut my site to the specific area, and if I would like, I can then export this data set to my client. If this was my exact area of interest, I would have exported it just as it is here. Alright, so before we send it obviously to the client, we just want to make sure that it plots in the correct position. So we'll just go click on save as, and because we can select the format, we know it's the most easiest format to save this file, or the JPEG in a KMZ format. So we'll just go to field exercise and just click on to client, and then we'll just save this as an ortho to client. Alright, it's called revision 0, and we'll select this as a KMZ file, click on save, and then click on save again. As you can see, it's saving. And what 3Dsurvey will now do is, as soon as it has saved the file, it will pop up in the folder that it has saved it. We'll then click on it and then see where it plots in Google Earth. Right, as we can see, it popped up and we want to see where it plots in Google Earth, so we'll double click on it, open up our Google Earth, close it. Sometimes it will take a short while to load because it's quite a big file for Google Earth to load. It's about 50 megabytes, but as soon as it gets its bearings, it will move quickly to the part where you have actually exported it. So what we can see immediately is it is plotting on the exact position as where the survey is actually supposed to be. And that's really great news to us. It means that we can, with the ease of heart, send this data to the client as final and representable data. So let's go back to our 3Dsurvey and go to our point cloud. Over here you can see, as I've mentioned with the hole filling, the actual points are going through the holes, which is what we wanted in the first place. Alright, so we can then also go to contours and then export these contours as a DXF. So we'll just export it as a 2D and then just put it as contours 0.5 meters. Alright, and then this will just be a normal 2D DXF. If you want for it to be a 3D, you can just click on the 3D function, and that is that. Another function we can then do is we can actually go to our mesh and then click on save as. Go to the to client option and then select this as a normal text file. So this will then be all your ground shots for every 0.5 meters, so that you can recalculate your data. If you've got other software where you want to generate your contours in, you can do it like this. So let's just call this contour data and also revision 00. And we'll click it on save. Right, so we're not interested in the color, we're just interested in the text file, and space is fine. Click on save, and now we've already got our KMZ file, our contours, our text file. So this file can be sent to a client, and this means that we are ready for our next job. Alright guys, and that's the end of the webinar. So first I want to say thank you for your time, and I hope there's something new that you have learned, and that the new function for the South African coordinate system that has been added to 3Dsurvey will make your life a whole lot easier and your workflow so much faster. So if there's any questions, please don't hesitate to send us an email, and we'll jump on your questions and make sure that we provide you with the best and most accurate answers. If you have not downloaded 3Dsurvey yet, please be sure to download 3Dsurvey in the link below. Thank you, and see you on the next webinar. We will be discussing PPK data that you have captured with your drone. See you in the next one.